Hello, so welcome back to discussion on waves. So today we are going to discuss about energy current. It is also called energy flux or intensity. So consider a region in which the wave is propagating through it. So it may be the energy through liquid or sound, or it can be energy in the form of sound, or it can be an electromagnetic wave, or some wave is propagating in space. Okay, so the wave propagation means there will be some energy transfer. The energy is propagating it. Okay, so my question is how much energy might be passing through a unit area in unit time? What is the energy crossing unit area in unit time? Now this quantity is called energy current. Now how we can find this? So consider this wave is propagating with speed v, and it will have some energy density u. So what we can do is, so we can consider a cylinder which is having some area A and its length numerically equal to the speed. Suppose the speed is 10 meter per second. I am going to take this length as 10 meter. Okay. Now what would be the volume of the cylinder? So by definition, volume would be the length times the cross section area. So V times A. Okay. So if U is the energy density, okay, remember the energy density is represented by symbol U, then what would be the energy inside the cylinder at some instant? Energy in the cylinder at any instant of time equal to the energy density times the volume. So U times V times A. Okay, so we already said that this wave is propagating with velocity V. Then what will be the energy inside the cylinder? It must flow through this shaded region, shaded area in unit time, because the length of the cylinder is only V. That is, suppose if the speed is 10 meter per second, then the length of this cylinder is 10 meter. So all the wave inside the cylinder must pass through this shaded region in unit time. So therefore, the amount of energy crossing this shaded area in unit time would be equal to the energy inside the cylinder. So since the length of the cylinder is numerically equal to the speed of the wave, the energy crossing shaded area of the cylinder equal energy inside the cylinder. Okay, so energy crossing shaded area of the cylinder in unit time equal to the energy inside the cylinder. And the energy inside the cylinder is, we already calculated, is equal to U times V times A. Then what would be the energy crossing the shaded area, or the energy crossing unit time in unit area? So therefore, energy crossing unit shaded area Okay, so there is not into required shaded the unit area in unit time, that would be equal to the total energy crossed divided by area, and it would be equal to U times V. Okay, so we have got the expression for the energy current denoted by symbol C or I. So we can denote by symbol C. So C is equal to U times V. What is U? U is energy density. And the energy density, we already found the expression for it. The energy density is half rho omega square A square times V. So this is the expression for the energy density, or it can also be done by symbol I, the intensity. So the intensity is half rho omega square A square times V. So remember, this intensity is directly proportional to the density, and it's quadratically proportional to the angular frequency or frequency. It's also quadratically proportional to the amplitude, and finally it is linearly proportional to the speed. So this is one important result. The intensity is quadratically proportional to amplitude. I is proportional to A square, amplitude square. So that's all about the discussion about the intensity and energy density. So in the next class, we'll be discussing the transverse wave in a stretch system.